Okay, these are the problems for chapter 14, and we'll do them one slide at a time. These are the problems in slide 15. Calculate the OH concentration for each of the following solutions and indicate whether the solution is acidic, basic, or neutral. The first A says we have an H plus concentration of 0.0505 molar. And we are asked first to calculate the OH concentration and then to indicate whether it is acidic, basic, or neutral. The first thing that I need to turn to calculate the OH concentration is the formula for Kw. I know that Kw, or the auto ionization constant for water, is equal to the concentration of OH minus in solution times the concentration of H plus or H3O plus. You can see it in both ways. Okay, I know what H plus is. I know what Kw is. I don't know what OH minus is, but I can find it out. So if I divide both sides by the H plus concentration, I'm isolating the OH minus, and this will be 1 times 10 to the minus 14, which is the value for Kw at 25 degrees Celsius, divided by my concentration of the acid, H plus, 0.0505, and you should get a concentration of OH minus of 1.98 times 10 to the minus 13th molar. Now let's think about whether the solution is acidic, basic, or neutral. Let's compare the concentrations of OH and the H plus. We know that a concentration is neutral if both OH minus and H plus concentrations are equal to each other, and they're equal to 1 times 10 to the minus 7th molar. Obviously, this is not the case, so this isn't a neutral solution. Now, in an acidic solution, the concentration of H plus is larger than the concentration of OH minus, and the opposite is true. In a basic solution, the concentration of OH minus is larger than the concentration of H plus. So let's compare. My concentration of H plus is 0.05, or I can rewrite this as 5.05 times 10 to the minus 2nd molar. This is my concentration of H plus. This is my concentration of OH minus. Obviously, I have a lot more acid, so my concentration of H plus is a lot larger than that of OH minus, which means that because I have an excess of H plus, that means that my solution is acidic. Let's look at part B. I have an H plus concentration of 2.5 times 10 to the minus 10th molar. Okay, I repeat the same thing. I have so the concentration of OH. I don't need to do this every time because I just showed you, but the concentration of OH is Kw over the concentration of H plus. Kw is still 1 times 10 to the minus 14th. Get used to this number, memorize it. H plus is 2.5 times 10 to the minus 10th. If I do this calculation, you get 4 times 10 to the minus 5th molar. This is my OH, and this is my H plus. Obviously, they're not equal to each other, and they're not equal to 1 times 10 to the minus 7th, so this is not a neutral solution. But now I need to figure out if it's basic or acidic. Once again, if you have a larger concentration of OH, that's basic, a larger concentration of H plus, that is acidic. If I compare these two numbers, my OH minus concentration is a lot higher than my H plus, which means that this solution is basic. And let's look at the last problem. I have C, a solution in which the H plus concentration is 1,000 times greater than that of OH. So I can write this as H plus is equal to 1,000 times greater, so 1,000 times OH minus concentration. Let's figure out what the OH concentration is. Obviously, because the H plus concentration is 1,000 times greater, I know that this is going to be a larger number than my OH minus, which means the solution is going to be acidic. But let's figure out what the OH minus concentration is. Okay, so if I go back to the formula, Kw is equal to the H plus concentration times OH minus. I don't know what the H plus term is, but I know that it is 1,000 times the OH minus concentration. So what I can do is take this term and replace it right here. So I can rewrite this. Kw is equal to 1,000 times my OH minus concentration, and times, I still have to multiply it by the OH minus itself. So what do I have? I have Kw is equal to 1,000 times OH minus concentration squared. To isolate OH minus, I divide both sides by 1,000. And I know Kw is 1 times 10 to the minus 14 divided by 1,000 is equal to the concentration of OH minus squared. Okay, if you do that, you will get minus, I've done it in one step and I'm trying to do it not in one step for you. So OH minus, from there, OH minus squared is going to be 1 times 10 to the minus 17th. And then to isolate OH, or to find the OH concentration, you take the square root of that number, 1 times 10 to the minus 17th, and it turns out to be 3.2 times 10 to the minus 9th molar. That is the concentration of my OH minus. And obviously, once again, I can go back and figure out the H plus concentration. I multiply this by 1,000, which gives me an H plus concentration of 3.2 times 10 to the minus 6th molar. So these concentrations are not equal. This is much larger. It's 1,000 times larger than this, which means that I have an excess of H plus ions, which means that this solution is also acidic. This is how you do these types of problems where you know the concentration of H plus or you know the concentration of OH minus. The relationship between the two is Kw. The product of the OH minus times the H plus is always going to be Kw. And unless it specifies at a different temperature, you're always going to assume Kw to be 1 times 10 to the minus 14th. Therefore, it's pretty simple. Once you know, because you know Kw, you will know the concentration of one or the other. You can calculate the last concentration that you don't know. Okay, I will erase this and then we'll move to the next slide.